Hello and welcome everybody to our webinar. My name is Thomas Cook. I'm part of the data management team here at SAS. I'm joined by Dale Ryerson, who is a principal technical solution architect. And my background is in ETL, MPP data warehousing, and big data. And Dale has a wealth of experience in analytics and helping clients develop our solutions. So we'll kick things off here. Here at SAS, we are passionate about helping our clients extract insights from raw data to drive better business outcomes. Our analytics software is used in every vertical from manufacturing to financial services to drive better decisions. Today, we'll look at one of SAS's newest technologies to enable real-time insights from raw streaming data. So we'll take a look at SAS event stream processing and who it's designed for, and also the analytics lifecycle and why that's important here. And then I'll hand it over to Dale to take us through a use case and example, show us the software. From connected car to connected factory, SAS event stream processing is being used across a number of different industries that are transforming from IoT and becoming data-driven organizations. SAS has developed from the ground up a standalone technology that is extremely agile and blazing fast, scaling from edge devices with minimal resources to the largest clusters. The design studio allows developers to quickly build applications that can process and analyze tremendous volumes of continuously flowing events where low latency incremental results are critical. IoT applications demand speed, agility, and scale. And SAS answered that call with ESP, which can easily handle millions of events per second with latencies in the microseconds, and all of this on commodity hardware. You have the flexibility to deploy the OS native application on IoT gateways or other embedded devices, all the way up to cloud distributed deployments. We have a solution that is fit for purpose for your IoT project. With edge analytics, you analyze and act on the data closest to the event source versus transmitting it to a data center or cloud for analysis. Intelligently filter events to greatly reduce the amount of data down to what really matters. This approach helps reduce latency for action responses, decreases the load on the network, and can reduce costs by not transmitting huge volumes of data, which can be costly, especially over cellular networks, like the connected car scenario we'll show you momentarily. So let's talk about in-stream and out-of-stream model training and scoring. This is an important concept. Out-of-stream training allows models to be trained on data that is at rest. This allows analytics to be trained on data that is larger in scope and history to provide a rich set of training data for accurate model development. In-stream model training can be used to retrain models as new events arrive, also known as machine learning. We provide text analytics to extract entities and understand sentiment. Geofencing allows you to test whether or not a subject is inside a geographic area or alert when it enters or leaves a particular area. We also understand the importance of data quality, providing a rich set of capabilities from our data quality tools to address business rules for standardization, parsing, and enrichment of data. I like to say you can feed the most sophisticated model in the world bad data. If you feed the most sophisticated model in the world bad data, you'll get bad results. So we understand why data quality is very important here. And our open architecture allows for you writing your own models in Python and C as well. SAS cares about IoT because of the path to value depends upon our sweet spot, analytics. To achieve value in a connected world, we first sense the world. Sensors provide those measures of the world, and that's the data. Then you need to comprehend what the data is communicating, gain insight, understanding, and context. With that understanding, that intelligence, we are ready to act on the data. The first two steps here remain largely an academic exercise unless organizations can put the insights gained from the analytics into action. That's how we capture value. The breadth and depth of our analytic capabilities remains a clear differentiator as IoT use cases can leverage our entire portfolio. In the industrial IoT space, this includes things like our asset performance analytics and field quality analytics solutions that are now augmented with event stream processing for real-time results. So let's take a look at a traditional analytics lifecycle. Data from operational data stores is typically loaded into an analytical data warehouse or data marts, and then models are then developed and executed on the data at rest, and then the results are fed to alerts, reports, and decisions are made. Streaming data is often treated as another operational data source and loaded into the data warehouse or Hadoop, where analytics are then performed on the data at rest. The main problem with this approach is that the time it takes to move the streaming data and load and query the data, most of the value in the data is lost. In order to compete in today's world, we need to act fast and not let the opportunity and value in the data slip away by not acting. That brings us to streaming analytics. By ingesting huge volumes of data, prepping the data into the format suitable for analytics, we perform analytics in real time and can now act just as the event has occurred. Here's where SAS event stream processing fits into this picture. We can apply high-end analytics on event streams offline. Data at rest can identify emerging trends, pattern detection at the event source, and then dynamically update the models in stream. And this is what this looks like. As we develop the models, we can train the models on data at rest. We can also score the data there. Then we can take the score code down to the streaming engine and score the data in real time. We can also train the data as new data comes through, train the models as new data comes through. We also have the ability to supervise with our model manager technology to take the best model appropriate and deploy that at runtime. Here's some different options for model deployment. You can write data step 2 or DS2 code, Python or C. We also have A-store scoring support, which is a SAS format. From other tools, you can export your models and import those directly, or there's model manager integration. Below is an extensive list of our streaming analytics algorithms, and several of these can be run out of stream with training in stream, and several of these will be coming in our upcoming release 5.1. We have hundreds of endpoints fully integrated in partnerships with several vendors in the IoT space, open source integration, Hadoop and Yarn compatibility, and cloud enabled. If your data source is not shown here, no need to worry. There's a publish subscribe API for writing your own connectors in Java, C++, or Python that is very simple to use. So get any custom device or sensor or application talking to ESP with very little effort. And with that, I will hand it over to Dale to take you through a use case and example.
Hi, my name is Dale Ryerson. I'm a principal solution architect here at SAS in R&D, supporting the Global IoT group. And I'll be talking today about event stream processing use case around connected vehicles. Now, with our connected vehicles, IoT really brings a wealth of different areas that we can now take a look at with fleets and connected vehicles within those fleets. And these can cover such areas as safety and security, quality, reliability, customer experience, fleet maintenance operations, location-based services, and the use case I'll be covering asset performance. Now, with streaming analytics, also the ability to take real-time decisions and big analytics, we can cover those different bases and have a lot of different specific use cases. I'll be going over just 2 of these many use cases, specifically around the predictive asset maintenance and also behavioral analysis. So when looking at streaming data, we're going to be collecting a lot of data. You're going to hear numbers coming off of connected vehicles anywhere from a gigabyte to terabytes worth of data. And you have to ask yourself, is all that data the right data? Do we need all of that data to make decisions? Do all that data need to go into our models? Can we transmit all that data? So there's a real question on how to handle that data, what to do with that data, because all that data needs to be prepped before we actually move into analytics. And as we take that data in, we want to move it through this value chain. And there's what you'll see with our event stream modeling is we take the data in and we move it through various steps, and each step adds value to the model. We want to take what you need to analyze, act on that data, and specifically because I like to say data has a half-life. Half-life because as the data sits around for longer and longer, the value of that data goes down. And the real important thing here is that it's not just connectivity and IoT that brings value to that data. It's going to be this bringing value or doing analytics at the edge. So I'm talking about actually being able to do analytics inside the vehicle. And why do we want to leverage analytics? Well, one, we need to filter all that data. We've got a lot of complex logic that we have to deal with. There's going to be a latency of getting data over to the data center. And so we need to act on that data quickly. Again, we've got that data as a half-life. There's a time sensitivity to all this and how we work with it. Even in a connected vehicle, it could be down to the milliseconds. So it's not cost effective to stream all this data. So how do we do this? I'll be showing, going over a slide example. So one way that we go is we're going to be monitoring fleets in real time. So we can take a look at things like the onboard diagnostic data that is just looking at things like fuel used, various faults that would come off these onboard diagnostic ports. What's going on with the vehicle? Is there ABS? Is there some stability? Odometer information. And the whole purpose of this is around asset predictive maintenance or predictive asset maintenance or asset performance analytics. You'll hear a lot of different terms used for this, and a lot of people will give a lot of examples, but the core idea is that we've got mountains of data, a lot of data sitting in that vehicle. We need the reduced cost, and we want to increase the uptime and safety of the vehicle. So how do we do that with analytics? Well, one way is we take the information and we run it through our analytic models. And so here is an example of some of the different types of data points that we can pull in, the number of faults, the type of vehicle it is, what the oil temperature, how much mileage is on the vehicle, and just some specific information about how that vehicle has been used or its category or model. And so depending on the type of information we're looking at, we can use things like decision trees to go in there and highlight the something like a turbo fault, and that's actually what this is. This particular model was to look at turbo fault prediction errors. And here we did a pretty good job of helping one vendor really reduce the amount of vehicles that they had to take a look at because we found these various categorical variables and also streaming variables coming that would highlight the vehicle problems. So again, main points here with the predictive asset maintenance is to take the information off of the vehicle, get it out at the edge, make decisions there, give the driver some feedback about what's going on in the vehicle, maybe share various endpoints of information with the driver before sending it up to the cloud and to our data centers. I'll go ahead and go to this next slide. I just want to put that up there as far as there's a couple of links I'd like you to take a look at. If you want a little bit bigger, a little bit larger over the structure of what we're talking about as far as the analytics, there's a real good one out there on the Cisco website where we've validated our edge analytics on the Cisco platform and lots of information about the software. Also, if you're interested in learning more about event stream processing, I have a link there over to our documentation, which is all online. It's very extensive. Please take a look. And also a nice little use case here about how SAS helps GE transportation. Looking at behavioral analytics, I'll be going through just a couple of examples. One having to do with decision trees, another one with our pattern matching and our K-means. So let me go ahead and stop there. Go over to our server image. So here we have information, and I'm not actually, since we've been talking, some of my stuff is timed out here, but let's go over to talk about what an event stream model looks like. So we have data coming in. The data has to go through a data prep. And so this is our event stream processing studio. It is a flow diagram of how data would move through the edge and give some feedback and also score and prep the data for doing analytics down the line. So coming in on the truck, we have a schema of data with a lot of different variables coming in, and that's shown over here in the property windows. It moves through the data prep. The data prep allows us to go in and build expressions and do key data prep items. Maybe you need to move it through a schema of different type of information, put some schematics or semantics on that data, and then also move that data over into areas where we start to throw various alerts and build key expressions that we can then take over into our models. We might want to pattern excessive behavior, such as speeding, or maybe we just have something that's going on with the vehicle, like vibration. So we can take a look at patterns and match those patterns directly against the data coming through as it streams through. We can then take that, join that information, and then ultimately score that either in line when the data streams in, or take that up to our data center and score the information there. So let me go ahead and jump back in and restart some of these services. So I'm gonna close this one, just so you can see the data streaming through. This is live. So we'll go in and start the data. We'll select the windows of data that we're want to look at. So I have just a real simple one here where we're streaming data based off of a time event. As we start to put the data in there, it should be connecting. There it goes. And as we move through here, it'll be grabbing data and updating about 100 rows at a time as it fetches data. As we move over to our stream viewer, we can see that data streaming through our visual dashboard and taking that information in. We can monitor the things that are going on in the vehicle, like the RPM, the speed, take a look at things like the temperature, voltage, and oil, and start to get a good idea of what's going on. So this is something that we could relay some of this information in our analytic model and provide it back to the data center if we need to monitor these types of stat in real time. Of course, you don't want to stream all this data, so one of the things I really like to show off is our Rest-Based Interface. So our Rest-Based Interface is something that allows just to see that the ESP is alive and working. Then we can go through and see the various projects. I have two very simple projects loaded here. And within those projects, we can see that we've got one here with what we call a continuous query with various information that is retaining data in various windows. And this is a very important concept within EventStream. So in each one of these windows, we want to go in and either aggregate information or just store it for a certain time period, because that becomes our sample as far as the analytics. So if we look at the information in 1 second, we've gone out and grabbed 10 values. The values, the data is streaming in at about 10 observations a second for this. So if I go change this Rest-Based Interface up here and just go grab 10 seconds and whoop, wrong window. Each one of these windows is uniquely named, and then this one has a plural on it. And so it's gone out there and now grabbed 100 events. And here we can see all the data values coming off of the streaming value. If I want to go out there and grab even more, here I'm grabbing 60 seconds, which is a total of 607 values. I'm only showing 10 of these, but the important part about all this is that we're going to aggregate and do our analytics across these various samples, and this time component is very, very important. So here I've shown a 1 second, a 10 second, and a 60-second sample. And for each one of those, I'm going to go and aggregate the information. So in this case, in this particular example here, I'm aggregating at the 1 second mark. The 10 second mark. And the 60 second mark. So again, taking each of those snapshots, we're going to get slightly different analytics, and this is just the real basic stuff where we're showing min-max values and aggregating and averaging the data. So once we have that data, what can we do with it? Well, we can start to do some of the analytics right there in the vehicle. We can start to take a look at how our driver maybe fit various behavioral patterns. So here I have a correlation matrix. It shows various inputs. And what you'll see is you do see very distinct patterns in these different profiles of data. So on my left hand, I have a normal driving behavior. On the top right hand, I have a person that has more issues with accidents, and so it shows up with a different profile with slightly different correlation information. And the bottom left is a speeder. Now it looks very similar to my first profile, but again, the numbers and the correlation break off slightly different. So this is one of the interesting parts about taking our data, looking at it aggregate, not just specifically, but taking all that information, and that's what we can do with the IoT data. We can also examine and look at the cluster information. If, for example, if we're looking specifically to analyze our damage over here, where we've had damage on a vehicle before, or we've had damage as far as what's been hauled by that particular vehicle, we can see that there's a particular pattern that shows up on many of these variables. And in particular, one of the things that we'll see, or one of the things that we see, is in the z-axis. So where we've hit a big bump, and we see a lot of acceleration in the z-axis and typically on accidents. So that's something to take a look for and a model for. And it's something that's very, very easy to go out there and look, as long as we have the acceleration type of sensors on our vehicle. Looking at a decision tree, we have on our left side here our speeder, and on our right is our normal behavior. And the way that the model breaks this down is, as we look at each of the flags, we can see that there are certain variables that get ranked based off of driving behavior. One of the most important being the displayed gear. Obviously, if you're speeding, maybe you're in a much higher gear. Your engine RPM might be very, very high, and you may be affecting the brake temperature. So all of these together go in, and the computer, the model, the decision tree here can really go in and see the differences in the driving behavior, and we can go in and profile people based off of this information. And then I'll throw it out there. We have neural net. There's been, I'm sure, a lot of people talking about the various AI capabilities within. I'm going to just leave it. We can do artificial intelligence on the data. How you would actually use that in stream, we still got a lot to learn there. So there's been lots of use cases, of course, that you've seen in this particular conference. I just wanted to delve in just a little bit more to complete that whole life cycle that we've been talking about, and that is once we have the information in the data center here, we're looking at it with our visual analytics. We can take that information, go deeper into it. We can go in and explore and work with that data, and ultimately we want to take that model that we've taken and export it back to our event stream processing to complete that life cycle. So the whole life cycle approach that Thomas has gone through, this is how we complete it. We've taken the data in, we've prepared the data, we've uploaded it to the data center. From the data center, we've done further training, and then we can take that information and take it back into our ESP model. And that's the life cycle. Let me finish here. So again, the whole idea behind our IoT life cycle is, again, get the data, produce some insights so that those insights can be shared both in the vehicle and also out in the data center. So we can do various use cases, such as predictive asset maintenance, and again, quickly feed that data into action. And that's the whole purpose of doing analytics at the edge with SAS. So if you have any questions about architecture, please go out and take a look at this site here at Cisco and SAS at the giving a real good overview of our edge to analytics capability. There's a lot of information here as Cisco has validated our software on their hardware. There's information here on event stream processing, how we work with Cisco's Fog Director, the 829 device that we can work on, and then also the various other pieces of the puzzle, such as SAS Visual Analytics, Visual Statistics, and the various hardware that Cisco provides that we can run on. Again, if you're looking for additional information, please go out to our website. Here we have our full documentation on event stream processing. Just wanted to give you a quick overview of all the different type of connectors that SAS ESP can connect into. And there's a good overview on how to work with this type of streaming data, how to work with events, how to take the data and move it and work with it in the life cycle. And again, here's one more website that you can go out and take a look at how SAS works with GE, and specifically GE Transportation, and also the Predix platform. So thank you for your time. From Thomas Cook and Dale Ryerson at SAS.